All right, guys, we're going to add to our new chapter here talking about exponential and this scary word. The first section we're going to talk about here is graphing exponentials. And as always, super important, hopefully we do the math lab that is attached to this first to kind of notice some things about what an exponential function looks like using Desmos, and also like when I start changing things up, what does that do to my exponential graph? And when you're all set with that, we can come back here and see how we're going to graph these, because we are going to graph these a little bit differently. You know, it does have the AH and K stuff that we're used to. But normally when we had those, we could kind of just do a lot of that in our head. Like we would just translate it in our head and then kind of do the slope from there. And because exponentials are a little bit more complex than that, we have to graph a little bit differently. So let's first go through and kind of point out the different things. So the first new thing that we kind of have with an exponential graph is we now have to consider this b value right here. B is the base of my function, which can also like kind of make the parent function change a little bit. So depending on our base, I might end up being a growth graph or something that is increasing at an increasing rate. Or I could be a decay graph. And if I'm a decay graph, we look like this, and we are decreasing at a decreasing rate. Are we? Yes, we are. And so the interesting thing about this is like B is kind of a slope number. And if you remember in the past, A has also been a slope number. So A is also slope here. And so we also need to consider A as my slope, but it's only slope to Y. So it's stretching me tall, not stretching me wide, or it's like stretching me up and down like this. So it's only being applied to the Y value. And that's kind of why, like when I talk about my growth graph, I'm saying two slope words, increasing, increasing, or decreasing, decreasing. And that's because I kind of have two slope numbers. B is a slope number and A is a slope number, and they're both going to like affect the graph. Really the main thing that we want to pay attention to is that it might start flipping the graph, like if it's negative, and that's a really big deal, but like A will also change other parts of the slope as well, so we want to keep that in mind. Luckily, however, H and K work the same. So H up here with X in the exponent is my horizontal shift, and it is always, always opposite, as it always has been. So like if I see a plus, I'm really going to minus, or like go left. If I see a minus, I'm really going to go right. And then K is my vertical shift. But hopefully what you also noticed is it has a lot to do with our range, and it's also our horizontal asymptote. This new word here, this asymptote, that kind of helps guide my graph a little bit. So an asymptote is something that we're going to get really, really close to, but never quite touch. So for example, if I have a big ol' function like this, where lots of things have happened to my exponential function, exponential because x is up in the exponent, we want to first actually identify our base. So taking our base function of 3 to the x, we are going to create a table using that 3 to the x. So that 3 to the x, we create a table. We're always going to use our base x values of -1, 0, and 1. And then we just plug them in for the x. So like when I put in -1 right here, we flip. And I plug in 0, anything to the 0 powers are always 1. And I plug in 1, 3 to the first is 3. Okay, so we always start with that. And really your parent table will always look the same. Like you're going to flip the first one, 1, and then keep the second one. So that's kind of nice. And here's what we're going to do. Once we have our table, and like we've never really graphed with a table before, we're going to take our table through our transformations. The transformations that we normally do in our head, we kind of need to write them out because, again, they're a little bit more complex this time. And so the next thing that we need to consider is actually the slope, the other slope. right here. And I need to multiply that slope to the y value only. Because again, it's only stretching me up and down. And so in my table, I did that. So I kind of took all these y values and I multiplied them by 2, because that's what my slope number was. It's like 1/3 times 2 is 2/3. 1 times 2 is 2. 3 times 2 is 6. And then after I do my slope, I can take it through its transformations. So the transformations that happened were that I went right 1. So opposite, we're going to add 1 to all the x's. So I take my x values and I add 1 to all those. Like +1 is 0, +1 is 1, +1 is 2. And then finally, I need to shift up 4. And when I shift up 4, I need to do that to my already slope increased y value. So we're doing it from here to here. And so I add 4 to each of those. So 4 and 2/3, 6 and 10. And then at the very end, we plot our final x and y. So like this is kind of our final table here, just the first and last one. So I went to 0, 4 and 2/3, 1, 6, and 2, 10. I also have my horizontal asymptote at 4 to help guide my growth graph. Okay, so now we're going to try a couple together. So overall, our exponential function with all the scary letters looks like y equals a times b to the x minus h plus k. Whenever we have growth, we will know that we have growth when b is bigger than 1, and it will sort of look like a J. We're going to know that we have an exponential decay graph or a decreasing graph when b is between 0 and 1, so kind of like a fraction, and it looks like an L. Okay. So we kind of already talked about this, but really quickly we can talk about b is the base. When b is bigger than 1, we are growth. When b is between 0 and 1, we are decay. We use b to get our guide points, so like our initial guide points. So we kind of want to start here. The second thing we need to do are any reflections or dilations. So the second thing to consider is our slope number. So if a is less than 0, which just means that we're negative, we flip over the x-axis. If a is bigger than 1, so like 2, 3, 4, 5, 6 sort of situation, you're just going to grow faster. And if it's less than 1, you're actually going to grow slower. So you still grow, it's just either faster or slower. Next thing I can do, and I can kind of do these two things at the same time, are my horizontal and vertical shifts. So horizontal shifts happen up with x, and they always happen oppositely. So like if I see x minus, I'm going to go right. And if I see x plus, I'm going to go left. If I see plus k, I'm going to go up. And if I see minus k, I'm going to go down. And this is also your asymptote. Asymptotes are super helpful. So what we could do is we could write an equation based on what they tell me. So write the equation. When the parent function of y equals 7 to the x power has been reflected in the x-axis, so that means that there was a negative involved, translated 5 units left, so plus 5, translated up 2 units, and vertically stretched by a factor of 3. Crazy. We have a horizontal asymptote at 2. Feels like my domain is always going to be all real. And then range is going to be y is greater than 2. Oh my goodness, no, not greater than. I spoke too soon. We got flipped, so less than. But always 2 because it is based on your asymptote. Okay, so now let's graph some. I Don't mind doing these, but I am a much more visual person. I'd rather see the graph. So looking at this one here, I'm going to identify my parent function. It is a base of 3. So we're going to be 3 to the x power. And since it's 3, that tells me we are growth, and we're going to look like this. We have a horizontal asymptote at -4, which is super helpful to put on my graph. I always add it because it's a nice guide for like how low the graph goes. Okay, so here's the thing. Kind of hate it. Put them in a weird order. Let's change these. These are going to be our x values. I want them in actual order. So -1, 0, and 1. And then we're going to get our initial y values. So the way we get our initial y values is we plug these into our base. When I plug in a -1, can't have negative exponents, so it flips. I plug in 0, anything to the 0 power is 1. And then I plug in 1, and 3 to the first stays the same. The second thing that we need to do is if I have another slope number, I need to adjust by that slope number. And I do, it's 2. So we're going to multiply by 2, and we only do it to the y values. So my y values right here, we're now going to double them. So 2/3, 2, and 6. Then I can take it through its translations. So the x value is being adjusted by +1, except for everything up here is opposite. So we're actually going to subtract 1 from each of the x's. So that'll be -2, -1, and 0. And then finally, we want to translate up or down, and we're going down 4. And when I go down 4, I need to go from my slope numbers. So I'm going to start with the easy one. So 6 minus 4 is 2. 2 minus 4 is -2. And 2/3 minus 4 is -3 and 1/3. Finally, we can go graph, and we want to graph our final points here. So after we've done everything to them, these are the x's, these are the y's. And so we'll go -2, -3 and a little extra. -1, -2. And then 0, 2. And so I can totally see that my graph is growing as I go this way at an increasing rate. I also notice if I go this way, it's like getting closer and closer to my asymptote. So I can totally see how I should sketch this graph out. It says to pick some extra guide points. I'm good with the 3 that we have. And so as far as domain goes, we got all real numbers. I think domain will always be all real for these. And then range, now I can really see on my graph that this graph is bigger than, or going up, above -4. And it will never reach -4, so that's why it's not equal to. Okay, let's try decay. So looking at example 3 here, I can see that my base is half. So we're going to start with our parent function of half to the x. And because it's half, that tells me that it's decay, which means we're going to look like this. I also noticed that we have some vertical shift over here, so that means my horizontal asymptote is at 5, and I can add that as a really nice guide point, or guide line. That feels weird, because like it's supposed to look like this. Anyways, also sorry about these. These are wrong again. Let's put our x's in actual order. So -1, 0, 1. And then we're going to plug them into our base function here. So like half to the -1st. I'm not allowed to have negative exponents, so I flip it. So 2. Oh my gosh, I had a moment there where I thought I wasn't recording. I'm recording. It's all good. When I plug in 0, anything to the 0 power is 1. And then when I plug in 1, it stays the same. So flip, 1 stays the same. Then if I have another slope number, I need to adjust it by that slope number, and I do. So my other slope number is -8. So we're going to multiply by -8, and we only do that to the y values because we're always stretching tall. We're not stretching wide. So if I multiply -8 by my y values, I get -16, -8, and -4. So these are my new y values now. I kind of don't need those anymore. And now we're going to translate. So when I translate, we're going to add 2 to the x's, and we're going to add 5 to the y's. And so if I add 2 to my x's, we're going to be at 1, 2, 3. If I add 5 to my new y's, we're going to be at -11, -3, and 1. These are my final points. So now we can go graph. 1, -11, 2, -3, and 3, 1. Oh, I see what happened. Okay, so like decay normally looks like this, but the negative had me flipping down, so that's why I can see this is now like increasing but at a decreasing rate, so that is why it's decay. Getting closer and closer over here. Okay, we're not doing that. Domain is always all. Range. This time we're below the line, so we're going to be less than 5 because we're getting real close to 5, but we will never be 5. Okay, hopefully that was a good graph review, and I'll see you on the next one.